All right, welcome back. And now that you've got your data centers and your servers done in your last exercise, now we just need to put it all together by creating the DNS Virtual Servers, either on the BIG-IP or on the generic LAMP server that you created. Then we need to create a pool to put those virtual servers into, and then we need to create a wide IP to represent that pool. Those are the three things we're going to do. So let's review. We already covered this in the last lesson. So again, a virtual server is actually just pointing to one of the objects on that server. So it's a subcomponent of any one of our server objects. So here I've got two virtual servers on server M, two subcomponents. So each server can host multiple servers, just like LTM. LTM quite often is going to host multiple virtual servers. It's very common. The BIG-IP DNS virtual server has a very similar commonality with an LTM virtual server. It's represented by an IP address and a port, and it's representing an application. But that again is a BIG-IP DNS virtual server. We also talked about this, the fact that the IP address, this is what is being sent back to the client for query, DNS query resolution. The port is being used for any monitoring that we're doing. If we're choosing to do monitoring, that's what is going to be used. So to add this virtual server object into a server object, if we have any non-BIG-IP objects, those generic hosts that we created, we have to manually create those virtual servers. We have to manually put in the IP address and the port and so forth. But, as we saw earlier, with BIG-IP objects, we can use the virtual server discovery if we choose to, or we can do it manually. We have that option. So if I'm going to do it manually, either with a generic host or with a BIG-IP object, I first am going to come to one of my server objects, either one of those, and then drill down into it. And as a reminder, we could have done this when we created the server object as well. We have those fields at the bottom for the virtual server. But now, after the fact, I have to come to the Virtual Servers tab here, where I will see all of this. I can enable virtual server discovery, but that's, again, only for BIG-IP server objects. I'm not talking about a BIG-IP server object. I'm talking about a generic host here. So I have to just go to the Add button. And again, it's really just a matter of giving it a name, an IP address, and a port. That's it. Nothing else. Translation address, if it's behind a NAT device, that's it. Now I can see I have one virtual server object inside of that server object. And that server object maybe only hosts one virtual server, and we're done. But now let's talk about how to do this automatically on a BIG-IP system. Again, we'll have to drill down into the device itself, the BIG-IP, the Seattle BIG-IP. We'll go to that Virtual Servers tab. I just choose Enabled. Again, which I could have done when I created the server object. Note it cannot be used to discover virtual servers that are NATed behind a firewall. Those have to be done manually and use that NAT translation address. When I'm done, I can click on Update. And now this could just take a few moments. Again, this is something that's available because of the iQuery protocol. But after a few minutes, we may notice there are 4 virtual servers. And if I wanted to, I could actually drill into there and go back to the virtual servers page, and I would see them all listed as well. Actually, even quicker, I could just click on that 4, the link. It would show me the 4 virtual servers in question. So now I want to utilize this concept of the GSLB for global load balancing. So now we're going to talk about how to set up the load balancing of these different virtual servers that we have. Remember, we may have 4 or 5 or 6 virtual servers all representing, for example, my public website. And those virtual servers might be located all across the world. And those virtual servers, remember, are all contained inside of a pool, an DNS pool. There are 4 entries that we have. So BIG-IP DNS uses a tiered load balancing model. What that means is we can actually have 2 pools. We talked about this a little bit ago. Each wide IP can have 2 pools configured. Why might I do that? Well, this pool might be in Seattle. This pool might be in Singapore. And I always want my HV application available. So all 4 of these virtual servers are somewhere either inside of Seattle, or maybe we have 2 data centers in the US. And these virtual servers are spread across 2 different virtual data centers in the US. This might all be in EMEA, across different. And now we can actually do a variety of different load balancing methods across both of those. We want to do some intelligent load balancing, which we'll talk about in a minute. For example, if I'm connecting from Sweden, I don't want to be sent to the US sites, I want to be sent to the EMEA sites. And we can do that because DNS has lots of different ways that it can make decisions on which of these IP addresses to send back. So just as a reminder, as review, we use load balancing amongst this pool to pick one of those 4. But we also use load balancing amongst multiple DNS, decide which pool to send it to, and then which virtual server within the pool to send it to. So 2 tiers of load balancing are in play here. Here's an example. Kind of talked about this, but now you can see it spelled out. So we have 4 data centers. One in Seattle, one in Richland. Those are, of course, both located in the US. One's a physical data center, one's a cloud. Again, that's irrelevant. We have a couple over in APCJ. One in Singapore in a physical data center, one in Mumbai, India, in a cloud. So we have 2 DNS servers. One DNS server is located somewhere in the US, another DNS server is located somewhere in APCJ. We have server objects. I have a server object for LTM, another one for LTM, another one for LTM, another one for LTM. Again, those don't have to be LTM server objects. We're just using that because that's what we want our customers to use as our LTM, as our server objects. And we're only now going to be talking about one web application only, our HTTPS public website. So we have one virtual server, but as a reminder, this virtual server is also doing load balancing across those 3 servers. We have another virtual server, load balancing across 2, and so on and so forth. So our goal here is that all users are going to be routed to the least utilized data center within their region, but we want to send them to the region that's nearest to them. That's our goal. So the first thing we're going to do, we're going to add all 4 of the big IPs as server objects on both DNS servers. We're going to add all 4 virtual server objects. So each server object will have the corresponding virtual server object in question. These are now BIG-IP virtual servers. Same virtual servers over here. We have 4 BIG-IP virtual servers. Do you remember what the next thing we create after we create the server object and the BIG-IP virtual server object is? Do you remember what the next object is that we create? And you swim in them too.
Yeah, I was going to say it's going to be the pool.
It's going to be a pool.
Yep. For
So
those
now for each DNS server, we're going to create a pool.
Right.
And here we're going to call the pool US pool. Over here we'll call the pool APCJ pool. It's important to note that each DNS server can route traffic to both pools. So for the HVS website, it's going to use this pool and that pool. For this HVS website, it's going to use each pool. And of course, all of those virtual servers will be added. Actually, no, excuse me. Over here, we're only adding these two to the US pool. We don't want to put these in the US pool. They're not in the US. We're only adding these two to the APCJ pool. Now, each one of these pools, as you may recall, has its own load balancing method. So because of our goal, we want to send it to the least utilized virtual server in their nearest data center. We're going to use the least connections load balancing method in each one of those pools. Now, each one of these DNS servers is also going to have Wide IP created for www.lorax.com. Remember that a Wide IP can point to multiple DNS pools. So we are using as the load balancing method for the Wide IP a load balancing method called topology. That's what enables us to use geolocation. So I could find whoever's requesting this, I could figure out their IP address, and then send it to an appropriate data center based on that. So now I'm going to have a couple of entries in my topology record, the way that we do topology. The first entry in the topology record is if their country of origin is North America or South America or Europe. Either one of those three, I'm going to send their DNS requests to the US pool first and the APC pool as a backup. As a backup. We're not load balancing here. We're only doing topology. This is only as a backup. Then I'll create a second entry. The second entry says if they're connecting from Asia or Australia, they're going to send it to this pool first and then use that pool as a backup. And notice I'm doing the exact same two things on this, just two different topology records. And they are not going to overlap, so I don't have to worry about order of precedence here. There's no overlap of those two entries. They're either going to be here or they're going to be here. So now let's talk about how this works. This guy comes from Australia. He's going to Australia. His local DNS. Hey, do you have an entry for www.lorax? Nope, it's not in my cache. So I need to go find your lorax.com server. So the first thing I have to do is go to the dot server, then the com server. The com server is going to point to either one of these. It doesn't matter which. It's going to point to the nearest one. Whichever one is nearest. And this is going to be the lorax.com DNS server that we're routed to. Hey, that's odd. I'm not in US. Well, that's okay. That's just where it's saying, hey, where's the next? Do you have an entry? Do you have an entry for www? It doesn't really matter so much where we're getting our IP addresses. What matters is where are we sending the user for their web pages. That's what matters. So I don't really care which DNS server answers the queries. What matters is what IP address I'm sending them to. So it says, hey, do you have an entry for www? Well, hey, I sure do. There it is right there. It's my Wide IP. Great. So now we're going to look. Hey, what's your IP address? You're coming from Australia. So guess what? We're going to match this topology record, which means I'm now going to send you to one of these virtual servers. You're going to get one of those as your IP address. And now we're going to use the least connection. Which one of these two is the least utilized? Oh, that one is. So now that's the IP address we're sending back to the client, which now enables the client to go directly to the right web server in Asia to get their web page. So that's how that works. That's a really good example of how we set all this up with multiple data centers. So how do we do this? We have to create those objects. We have to create the pool, and we have to create the wide IP. We've already created the virtual server earlier in this lesson. So pool, note we are going to GSLB pool, not LTM, not local traffic pool here. We're going to give the pool a name. What was our first pool again? Our first pool was the US pool, the www.us pool. The type is going to be what type of record we're returning. Remember earlier we could return a CNAME record or an A record. In this case, we're sending back address records. That's what this pool does. So we're going to use the A record type. These are some optional things we can add, health monitors and availability, what to do, certain ones are not done. But let's talk specifically. The important part is, where is this pool sending requests? And that's all done down here under the members. We have our different load balancing methods. So as a reminder, the pools are supposed to be configured with least connections. All of our load balancing methods there, so we can choose least connections. Now, possibly, DNS may not always have what it needs to know about that virtual server to make a least connections decision. It's very possible. That's why we have these three options: preferred, alternate, and fallback. I want to use least connections as my preferred load balancing method for my pools. But if DNS can't make a determination about that, I can pick a secondary for my as my alternate, and then if those two don't work, I have a total fallback that I can use. I can just actually have that return to DNS and have DNS pick it randomly if I wanted to. So I'm using least connections as my preferred, but if that doesn't work, we'll just do round robin within the pool. And if that doesn't work, we'll just go to DNS and let it do what it needs to do and pick a decision. And that's the DNS server that we can send it to. So I could just send it to any other DNS server that I configure here if I want to. So here's where I'm going to select those two virtual servers from Seattle. Only the two that are in Seattle go into the Seattle pool. And I can see all four of my virtual servers I added: the one in Mumbai, the one in Richland, the one in Seattle, the one in Singapore. So obviously I don't want to add Mumbai or Singapore here. And remember, these virtual servers were either added manually or automatically with discovery. So I'm going to add the first Seattle Lorax.com, and then as a second, I'm also going to add Richland Lorax.com. Those are my two virtual servers that are going to go into the Seattle pool. And then we're done with that. We'll go ahead and click on Finished. Then we will do the APCJ, or the APC pool, which also has two virtual servers. What?
You're like 10 minutes into her time?
Yeah, almost done. I've got like 2 more slides. I just want to let her know that she's not looking. Okay. So now we have our 2 pools ready to go. The last thing is our wide IP. We need one wide IP for www.lorax.com. That's going to send it to either the Seattle pool or the APC pool based on topology. So I go to my wide IPs. I'm going to create my wide IP. The name of this wide IP has to be that host name that users are using. That has to be that name. That's very important. The type, again, we're still doing the same thing. These are A records. Same idea. And then if we scroll down, here's our next load balancing option. Remember that this is the load balancing method used by the wide IP, which we said we wanted as topology. Notice there's not as many options available here for wide IPs. So I'm going to use topology. And now we just have to select the 2 pools. Which are the 2 pools available? And there's the 2 pools I just created. I can add them both. We want to direct to both pools based on geography. So I'm going to add the APC pool, and then I will also add the US pool. And then we're done. We'll click on finished. Now at that point, in some cases, we're done, depending upon the load balancing method that we chose. However, we chose the topology load balancing method. So we have one more thing we need to do. We have to create those two topology entries that identify where they're connecting from and which pool to send it to. So that's the last thing we're going to do here. We go to our GSLB topology records, create a new topology record, and basically what we're doing here is identifying them, identify the source, and what to do with them. Who are they? Where do I send them? So, first, for the origin, I'm going to say if they are connecting, I could say by region, by country. I can even go as high as continent, which is actually what we want. I don't want to pick and choose every EMEA country. That'll take too long, but we could. But I say by continent is, and then I'll change unknown. But look, there's my continents. So I can say if they're connecting from North America, then what I want to do with the North America requests, the destination is where to send that. I'm going to send it to a DNS pool. So there's our options there. But I'm going to go to a pool. That's a DNS pool, important to note. And then there's the two pools I created, APC pool and US pool. In this case, I want to send it to the US pool. And then I click on finish. Oh, the weight. The weight we're going to use to determine if I have two entries that overlap in some manner. There's some sort of an overlap. The higher the weight, that entry will take precedence. But in our cases, I already said, our topology records are not going to overlap because we're not going to mention the same continent in two topology records. So I can just click on finish, but I guess I'm going to give it a weight of 10. That's fine. Now I can add a couple more. I can add a few more topology records. So I have a topology record that says if they're from North America, go to US pool. If they're from South America, US pool. Europe, US pool. Asia, APC pool. Oceania, APC pool. And, actually, I lied. I do need the weight because this is the backup. I remember I need the backup. What if this whole area is down? There's no way to send them to that pool. Then we have the backup. Okay, the backup, if they're from North America, go to the second pool. And notice all of these entries have a lower weight. We're going to do this exact same thing on our APC DNS pool. Our APC DNS server. The only difference is these will kind of be switched. So all the APC pool items will have the higher weight, and the US pool items will have the lower weight. So those are the entries for the high priority. These are the secondary backup priority. Look how easy that is, just with those. And that is what we need to set it up. So your last exercise is you're going to go in. You've already got your big IP object created from your first exercise. Now you're just going to use the discovery to find the virtual servers on there. Then you're going to create a couple of DNS pools. Then you're going to create a wide IP and then test it out and see what happens as a result and what IP address you're getting as your query result. That's the whole key. And we'll take about 40 minutes for that, and then we're all done. Thank you very much.